Today, we learn how to solve this equation by matrix method. Before we start, let me tell you something very important. Doesn't matter what form of the equation is given to you, I always recommend you to keep this equation in the matrix format. And what is the matrix form? Let me just tell you. You have to put this equation in this way. Look at here. 2x minus 3y is equal to 1. Okay, this is the first equation. And the next one is 3x plus 4y is equal to, it's a 10. Remember, always you keep the equation in this form before you solve this by the matrix method. Okay, now we are converting these two equations in the matrix form. See how we do that. You are just taking the coefficient of the x and y here, horizontally and vertically. Look at the first equation. Here the coefficient is 2 minus 3. So you just take like this. 2 minus 3. Okay, it's not only 3, it's a minus 3. Remember, in front of the y. And the second equation has the uh, we have the coefficient is a 3 and it's a 4. Okay, this is the, we are converting the given equation in the matrix form. Now in the next matrix, let's take the only variable. Here you can see x and y are the two variables. So let's arrange it in this way, x and y. Don't look at the sign, just simply x and y we are taking here. And finally we are taking the constant, and I'm just taking like this 1 and 10 here. Okay, so this is the way how we arrange the given equation in the matrix form. Some of you must be wondering that how we did it, how it is possible. Let's look at here. See, from here, if you just look into these two matrices here, see, if we multiply these two matrices, what will happen? Let's see it here. Okay, you know that this first matrix is a 2 into 2 order, and the second one is, this one is the 2 into 1 order. Okay, here you can see clearly that column of the first matrix is equal to the row of the second matrix, and you know that we can multiply these two matrices. And how we multiply? We just take horizontal and it's a row and a column. Okay, so how we do that? Let's see it here. First row multiply with the column here, so it will be something like this, 2x, and then minus 3 with the y, so that will be minus 3y. Okay, now here another one. Now see the second row we multiply with this column, so it will be something like this, 3x and then 4 with the y, so it will be the plus 4y. Okay, we are multiplying the row and column, so this will be equal to, now it's a 1 and 10. And as you know that if the matrices are equal, then their corresponding components are also equal. So here you can see 2x minus 3y will be equal to 1, and 3x plus 4y is equal to 10. Now you can clearly see here, when we multiply, we are getting exactly the same equation once again. So now you understood that how it is possible to uh, you know convert the given equation in the matrix form. Okay, here we arrange the given equation in the matrix form. You understood how to convert them into the matrix form, right? So let's consider this, the first matrix, as A matrix, and the second one, this x and y variable matrix, as X matrix, and we consider this as B matrix. See, if we just consider, if we just suppose this matrix as AXB, then it will be something like this, AX is equal to B. Okay, now here, now we multiply these equation on the both side. We pre-multiply, not only multiply, we pre-multiply both sides by its inverse, A inverse. We can just multiply it like this, AX is equal to A inverse and a B. Look at here, we are just multiplying on the both side by the A inverse. Okay, inverse of A. Now why we are doing so? Because you know that when we multiply any matrix by its inverse, what will happen? We'll be getting the identity matrix. Okay, So identity matrix. So Ix will be equal to now A inverse B. Now, when we multiply any matrix by its identity, then what will you get? We'll be getting here as a X is equal to A inverse B. Okay. So we need a unique solution of the X here. That's why we multiply on the both side by A inverse. One important note, just remember that if you multiply any matrix by its inverse, for example, A inverse A, or if you multiply the post multiply like a and A inverse, remember we are always getting identity matrix. Just don't forget these important notes here. Okay, so here we got the unique solution of the X here. You can see it here. X is equal to A inverse B. Here now we have to find out here. We have already X here, we have a B matrix here, but we don't have an A inverse. So we need to find out the A inverse here. And remember, in order to find the A inverse, what we need to do first? First, we need to find the A determinant. Remember, if the determinant is the 0, then it is called the singular matrix. And the singular matrix doesn't have its inverse. So let's first check this inverse here, okay? Determinant of the A matrix. Now look at the matrix here. Here is a matrix 2 minus 3 3 4, and what will be the determinant here? We just multiply 2 and 4, the main diagonal, 2 into 4, okay, and then here minus, and here see the main it's a secondary diagonal here, 3 and minus 3, so we just put minus here and then 3 times minus 3, okay. This is the way how we get the determinant here. Let's check it. So 2 times 4 is 8, and minus minus will be plus, and 3 threes are, it will be 9. So that will be equal to, now it's a 17, right? So which is not equal to 0. So what does it mean? It means that therefore A inverse exists. Now see here, A inverse exists. Now, we need to find out the A inverse here. Okay, how we find A inverse? All of you know that A inverse is equal to 1 by A determinant, and what we do? Adjoint. We take here the adjoint of A. Okay, you just call it adjoint of A. So here we already got the A determinant. Now we need to get the adjoint of A. So uh, here, let's see how we get the adjoint of A. Look at the matrix here. Here it's a 2, 4, minus 3, 3 here. You can see here the matrix A here. While getting the adjoint of A, what you need to do? The main diagonal, you just interchange here, main diagonal. So here you will be writing 4, and here you'll be writing the 2. Look at here. The main diagonal, we have a 2 and 4. I'm just interchanging here. Okay, 4 and 2. And this minus 3 and 3, here you just change the sign only. So here will be the minus 3, and since here is the minus 3 already, so minus minus will become here plus. So I hope you understand how to get the adjoint of A. Okay, now we can easily find out here the A inverse now. So what is the A inverse? So this will be equal to 1 by A determinant, and that is the 17. And here it will be the adjoint of A is 4, 3, minus 3, and 2. Okay, I will suggest you not to divide this matrix by this 17. Do not multiply by 1 by 17. Just let it be like this. Now, here we know that we have a unique solution is X is equal to A inverse and B. Okay, so what is the A inverse here? It is 1 by 17. And here the B matrix is here. Okay, it's A inverse, that is a 1 by 17 and 4, 3, minus 3, and 2. Okay, and here what is the B matrix? It is 1 and 10. Okay, now we can multiply these two matrices, and you know how to multiply this. So let's multiply these two matrices here. Okay, 1 by 17 as it is here, and let's multiply this row column and the row column. So how we do the first one? First row, let's take the first row. 4 into 1 plus then 3 into 10. Okay, 3 times 10 here. Now let's come to the second row. It's a minus 3. Let's begin with the minus 3 here. It's a minus 3 times 1 and plus then 2 times 10. Remember, while we multiply, we just take the corresponding component of the row and column. Okay. Now here, what will we get? Let's see here. It is 1 by 17. Okay. And here, what we get here, it is 4 plus 30. Okay. And here we are getting minus 3. Here is the minus 3 and plus 2 times 10 is 20. Okay. Now here, let's look at here what we get here. It is a 1 by 17. And here we are getting here 4 plus 30 is 34. And 20 minus 3 gives you the 27. Okay. Now look at here. What we can do here. After that, see, this is equal to, we can see here 1 by 17. Okay. Here from here, we are getting 34 and 34 and 27. Okay. You all know that we can multiply this matrix by the scalar 1 by 17. If we multiply means we are dividing by 17. So what will we get if we divide each component by 17? We'll be getting here 2. Okay, here. I think I made a mistake here. Look at here. It is here. It's a 34. And if you look into here, I just made it just wrong. It's a 20 minus 3 is not 27. It's a 17. Just remember, okay? I made a little bit mistake here. So here I can just write it. Let me change this one. It is 17. Okay. I just made a calculation mistake here. So this will be the 17. And if you divide 17 by 17, then we'll be getting just 1 here. Okay. So we'll be getting what? Let me just divide it. Okay. Here. If we divide this 34 by 17, we'll be getting 2. Okay. And if we just divide 17 by 17, then we'll be getting 1 here. Okay. Now here, from here, this is x. We know this is x here. So we can just simply write here the variable in the matrix form. This is the x and y. Okay. Now if you look into the corresponding component, then what can we do here? X is equal to 2. We can just take the corresponding component. X is equal to 2 and y is equal to 1. Okay, now this is it. Okay, this is the way how we solve the given equation by the matrix method.